Hello friends, I welcome you in lecture number 4 on the method of separation of variables. In this lecture, we will solve this partial differential equation using the method of separation of variables. And this question was asked in GTU Summer 2020 as well as Summer 2022 exam. So here we observe that in given equation, we have partial derivatives of function u with respect to x and y. That means our dependent variable is u and it is a function of two independent variables x and y. So we have to find out the unknown function u of x and y which satisfies this equation. So first we write down this equation and then we will apply the method of separation of variable. Given partial differential equation is del u by del x plus del u by del y equal to 2 times x plus y into u, and we give this number 1. Now we know that we start the method by assuming that our solution u is in the product form. It is a product of two functions, one for function of x and another is function of y. So we start by assuming that, suppose that one has equation 1 has solution of the form uxy equal to capital X, which is a function of x only, into capital Y. So this is the product form of the solution. Now because this is the solution of equation 1, it must satisfy equation 1, and in equation 1 we have partial derivatives of first order with respect to x and y. So first we write down del u by del x. For del u by del x, we consider y as constant and derivative of x with respect to x is denoted by x dash and y as it is. And similarly, for del u by del y, we consider x as constant, derivative of capital Y with respect to small y is denoted by y dash. And then we substitute these derivatives in equation number 1. So what will be the equation 1 now? Therefore 1 becomes, in 1 left hand side is x dash times y, that is ux, left hand side is ux plus uy. So we take ux equal to x dash y plus uy is x into y dash. Right hand side is 2 times x plus y into u, and u will be replaced by x times y, capital X into y. Now we divide this whole equation by capital X into y. That is, we write one more step, x dash y plus x y dash divided by capital X into y, and here we will have 2 into x plus 2 into y. Xy divided by xy is 1. Therefore now we divide x dash y by x into y, so y will get cancelled and we have x dash over x plus x y dash divided by x into y, so x will get cancelled and we have y dash over y, and this is equal to 2x plus 2y. And we are trying to separate the functions of x and y. So we transfer this function on the left hand side, that is x dash by x minus 2x equal to 2y, and we transfer this on the right hand side, 2y minus y dash divided by y. And now we can see that on this side we have function of small x only, on this side we have function of small y only, and this is possible only if both the functions are equal to the same constant. So here we can write that this equality holds, if this equality holds only if both sides are equal to the same constants. Both sides are equal to the same constant that we can denote by, say, small k. Therefore, we write x dash over x minus 2x, this is equal to small k, and both sides are equal to the same constant. Therefore, 2y minus y dash over y, this is equal to small k. Therefore, x dash over x can be rewritten as k plus 2x, and here I transfer y dash over y on one side, and this k is with 2y, that is 2y minus k. Y dash over y equal to 2y minus k. Now here we can observe that this is first order ordinary differential equation in x, and this is first order ordinary differential equation in y, and both are separable. Here we can say that we have two variables, capital X and small x, and this is separable in capital X and small x. Similarly, this is separable in capital Y and small y. So we can directly integrate. Suppose I give this number 2 and say number 3. Let me see whether I have given numbers before this. So 1 is given, 2 is given. So we can use 3 and 4 here. So if I take integration for equation number 3, I can write that from equation number 3, integral of x dash over x, that is going to be log x, equal to integral of k plus 2x, that is k into x plus 2 into x square by 2, so 2 will get cancelled, plus constant of integration that we write as logarithm of some constant, say c. Therefore, now I consider these two terms together, log x minus log c equal to k into x plus x square. Using the property of logarithm, this I can rewrite as log of x divided by c equal to kx plus x square. And as we know that logarithmic function and exponential function are inverses of each other, therefore x divided by c is equal to exponential of e to the power kx plus x square, and therefore capital X is c times e raised to k times x plus x square. This is one function in the product solution, which is capital X, and it is a function of x only. We will obtain another function capital Y by solving this first order separable ordinary differential equation. Here also we integrate both sides with respect to y, and here also. So integral of y dash over y, that is going to be log of y. From equation number 5, here I have given number 4. From equation number 4, what we can write, integral of y dash over y, that is log y, equal to integral of 2y is 2 into y square by 2, that is y square minus k into y. So here I have y square minus k into y plus constant of integration that I adjust as log of c dash. Therefore log y minus log c dash equal to y square minus k into y. Therefore logarithm of y divided by c dash, this becomes y square minus ky, using the property of logarithm, and therefore what we obtain, y divided by c dash equal to e to the power y square minus ky, and finally we obtain another function also, y equal to c dash times e to the power y square minus k y. And once we obtain these two functions, then we can write down the required solution. Therefore, the required solution, it is the product of these two functions, capital X and capital Y. It is u equal to x into y. Therefore, u equal to c times, first we write down capital X. It is c times e raised to kx plus x square. C times e raised to kx plus x square. And what is capital Y? It is c dash times e to the power y square minus ky. So here I write y square minus ky. And therefore, if I combine these two constants, they are arbitrary constants. I consider c into c dash equal to some another arbitrary constant, say capital A. Then I have e raised to kx plus x square into e raised to y square minus ky, where this capital A equal to c times c dash is arbitrary constant. And this is our solution for the given partial differential equation, u equal to a times exponential of kx plus x square times exponential of y square minus ky. So this is very easy problem. You just have to start by the assumption that equation has solution in this form, product of functions of small x and small y, and then by substituting values of del u by del x and del u by del y, and by doing this procedure we obtain two first order ordinary differential equations in capital X and capital Y, and which are separable again, so we can directly solve them by doing integration. And once we obtain capital X and Y, our required solution is product of capital X and Y. So this is all about this session. I hope you like it. Thanks for watching.